Hello everyone. Today we are going to see how to calculate the compressive strength of cement mortar cubes. So this is the testing machine. So these are the molds of size 70 mm by 70 mm, and these are the trowels, and this is the another cube. So this is another cube of size 70 mm by 70 mm, and that is the third cube 70 mm by 70 mm. So here we are going to take the fine aggregate in three types, that is coarse, medium and fine sand. Okay, so this is the fine, so this is the medium what you are seeing, and this is the coarse sand. So these are the three types of sands we are going to take, that is coarse, medium and fine. So this is the fine sand particles of three different sizes: coarse, medium and fine. So according to Indian standard, the size of the coarse aggregate is 2 mm, that too medium is 1 mm, fine is 0.5 mm. So this is the three grades we are going to see. So now we are going to take the cement about 200 grams. So you can see here the cement we are going to take out about 200 grams. Exactly 200 grams cement we are taking, that is PPC cement, that is Pozzolana Portland cement. So you can see here exact 200 grams of cement we have taken, that is PPC. So now we are adding fine aggregate of 0.5 mm size of sand. So each we can make equal to 800 grams of each mold we are mixing. So you can see we are going to take three grades. So now we are taking fine of size 5 mm, 0.5 mm. So total 800 grams we are going to take. Including cement and sand. Cement and fine aggregate is taken equal to 800 grams. So you can see here for each mold of coarse fine aggregate, medium fine aggregate and fine aggregate. So now we are adding fine aggregate of size 0.5 mm. So now we are adding again coarse aggregate, coarser one of sand of size 2 mm. So nearly about 800 grams we are taking, both fine aggregate as well as cement. So exactly you can see here 800 grams. So next we need to, so previously we have done the normal consistency of the cement, that is 33%. So by using the formula we are going to consider the normal consistency, that is P by 4 plus 3 into W by 100. So P is the normal consistency, that is 30%. So 84 grams of water we are going to take by considering previous normal consistency of cement, that is 33%. And now we are going to mix the cement and the fine aggregate particles, that is sand particles, as a fine mix together, homogeneous mix. You have mixed together in the pan. So you can see here both the cement and sand has been mixed homogeneously. So now we have to pour these two cement and sand on a horizontal plate. So now we have to pour the water, 84 grams of water, by considering 33% of normal consistency, that is we have taken from cement. Slowly we need to add the water about 84 grams by considering 33% of normal consistency. So with the help of trowel we have to mix slowly So slowly we have to mix with the help of trowel. So you can see here slowly we are mixing the cement and the fine aggregate of sand. Slowly with the help of trowel we are going to mixing. So you can see to make a homogeneous mixture. So usually the compressive strength of hardened cement is the most important of all the properties. Therefore, it is not surprising that cement is always tested for its strength at the laboratory before the cement is used in important works. Strength tests are not made on neat cement paste because of difficulties of excessive shrinkage and subsequent cracking of near cement. So here we are going to preparation of test specimens according to IS 4031 part 6 1988, that is methods of physical test for cement, determination of compressive strength of hydraulic cement other than the masonry cement. So you can see here we are placing the cube vibrator machine. We are pouring the mortar material into the cube vibrator machine. So after this, after 20 days of so we have casted now here represented by 3 cubes of 1, 2 and 3. So after 1 day we are demolding it. You can see here numbering 1, 2 and 3. So 3 cubes we are going to test to get the average compressive strength of the cubes. Slowly we have to demold one by one. So now you are demolding the cube number 1, which is noted as number 1 on the surface of the cube. So after demolding, the cubes has been kept in water curing. Similarly the 3 cubes 1, 2 and 3, which are immersed in water for 28 days. So you can see here cube 1 we are placed in water. Similarly cube 2 and cube 3, which we are going to immerse in water. So cube 3, the measured compressive strength of the cubes shall be calculated by dividing the maximum load applied to the cubes during the test by the cross-sectional area. So load by area, cross-sectional area. By using this formula, after 28 days of curing, we are going to calculate the compressive strength of the cement mortar cubes. Average compressive strength we are going to calculate. The compressive strength not consider specimens that are manifestly faulty, give strengths differing more than 10% from the average value of the test specimens. After discarding specimen strength values, if it is less than 2 strength values are left for determining the compressive strength at any given period, retest shall be made. So you can see here 3 molds, 3 cubes has been kept in for water curing for 28 days. So after 28 days of curing, we are taking out the molds. After curing 28 days of 3 cubes, you can see here we have numbered 1, 2, 3. Now they have been cured for 28 days in water. So now we are going to test the 3 cubes in compressive testing machine one by one. So now we have to switch on this compression testing display. We have to place the cubes one by one. So according to IR standards, the compressive strength of PPC we should get 33 Newton per mm square for 28 days of curing. So now you can see here, gradually we are applying the load. So you can see here, this is the compressive testing display. So we have kept these. So you can see here the cube numbering has been made, that is cube 1. So you can see here cube 1. Slowly we are applying the load. Green button we have to press and the load is going to be applied on the cube number 1, that we should note down in terms of kilonewton. So you can see here the gradually the load is going to be increasing as it touches to the surface of the cube, that is noted as cube number 1. So now you can see in the compressive testing display. So you can see here in the compressive testing display the load is going to be increased 2.8, 5, 6, 7, 9. So you can see here. Now the ultimate load taken by the cube 1 is 234.8 kilonewton. 230. So again you can see here the load is increasing gradually. So the load taken by the cube, you can see 234.8 kilonewton. The cube number 1 has been taken the load 234.8 kilonewton. Now we are placing the cube number 2. Similarly, we should apply the load. Similarly, we can test for cube number 2. So according to IS standard, the compressive strength of the cement mortar cube of Portland pozzolana cement we should get in the range of 33 Newton per mm square after 28 days of curing. So this is the standard value that we are going to get. By taking average, we can compare with the standard value. For second cube, the load carried is 218.2 kilonewton. So you can see here the load carried by the second cube. Similarly, for third cube, we are going to calculate the load. So you can see here gradually increasing the load. So the ultimate load we are going to see here. So the ultimate load carried by the Q number 3 is 245.0 kilonewton. So by taking this load and considering the cross-sectional area, we are going to calculate the average compressive strength. So you can see here these are the specimens after tested in compressive testing machine of Pozzolano Portland cement mortar cubes. To that IS standard, it should be valid with 33 Newton per mm square. So now the calculation part is going to be explained in the next video. Okay, so you can see here how the cracks has been observed on the second cubes. That is ultimate load that is carried by. Similarly, for third cubes, we are going to observe the cracks after testing in compressive testing machine. So here we are tested the compressive strength of cement mortar cubes. So we have taken the average of 3 cubes and the load that is taken by each cube. The first cube, the load that is taken in terms of kilonewton, 234.8 kilonewton, and the size of the cubes is 70 into 70, that is in terms of mm, and we have to convert this load into newtons. That is 1 newton equal to 10 kilonewton. So that is equal to, so this is the first compressive strength of the cement mortar cubes, that is 47.91 Newton per mm square. Similarly, for second cube, the load taken by the second cube is 218.2 kilonewton. We need to convert into Newton. So divided by cross-sectional area in terms of mm square. So the compressive strength of the cement mortar cubes taking this load will be 44.5 Newton per mm square. Similarly, for third cube, the load taken by the third cube, 245 kilonewton, to convert into newtons, that is multiplied by 1000 divided by cross-sectional area in terms of mm square, 70 by 70. So we get 50 mm Newton per mm square. So of these three, so we will get the average compressive strength of the cement mortar cubes. So we can calculate here. So here we have calculated average of these 3 cubes. So to calculate the compressive strength, we require 3 minimum cubes to calculate the compressive strength of 3 cement mortar cubes. So we get the average that is 47.47 Newton per mm square. So as per IS code, so so as per IS, we have taken the PPC cement of 28 days compressive strength, we should get 33 Newton per mm square. And here after casting the cubes, after testing in the compressed testing machine, we have got 47.47 Newton per mm square. So the minimum is 33, so we got 47. So we get the good results. This is the compressive strength of the cement mortar cubes.